Today we're going to be working on local winds. When I talk about local winds, I talk about sort of like local weather. It's where you are right now. So if you're sitting on a beach, you're going to be experiencing a local wind. And that's what we're going to talk about today. Local winds, land and sea breezes, and then mountain and valley breezes. Make sure you have your notes out and you are ready to go. So let's go through and get a little background information first. Wind is actually just the movement of air. Wind is always named for the direction that it comes from. So if it's coming from the east, it would be called an easterly. If it's coming from the beach, it would call a beach breeze. If it was coming from a car, it'd be called a car breeze. If it was coming from a tree, it would be called a tree breeze. It's always named from where it's coming from. And it's caused by differences in temperature. And what creates that difference is the uneven heating of the Earth's surface. The Earth itself doesn't heat exactly the same everywhere it is. It heats unevenly. And it also has to do with the difference in air pressure. We'll find that wind moves from high to low air pressure always, just as it will move from high heat to lower heat. Let's first look at that difference in temperature. We talked about this early on in the year when we talked about density. We talked about it when we talked about convection currents. So we know that warm air makes the molecules move faster and they spread out further and further, which makes it less dense and it begins to rise. So think about it. The less stuff there isn't much to hold it down. So it starts to rise because there's nothing holding it down. On the other hand, cold air sinks. So cold air makes the molecules start moving slower and slower. So to kind of get warm, they all start grouping together closer and closer. And if you think about it, the more and more stuff that's in one place is going to make it heavier, so it's going to need to sink. So it's called more dense when it's cold, and it causes it to sink or fall. When we put those two concepts together, they're kind of like what makes a lava lamp work. There's a light bulb at the bottom of a lava lamp, and it begins heating the wax inside. As the wax inside gets hotter, we know it starts moving apart. It becomes less dense, and when it's less dense, there's less stuff to hold it down, so it starts to float to the top. When it gets to the top, it's far away from that heat source. It's like you walking far away from a fireplace. As you get further and further, you're going to get colder and colder. The same is with the lava lamp. As the wax gets further and further from the heat source, it gets cooler and cooler. So it kind of has to bunch all back together trying to get warm again. So while it's doing that, there's so much that gets together that it begins to fall. It falls because it is more dense, because it's all clumped back together. More molecules in a smaller space. Once it hits the bottom again, it's closer to our heat source, and it begins warming up. And the whole convection current starts over. So we know one thing that controls the movement of air is that difference in temperature. The other thing is the difference in pressure. We talked about air pressure, high pressure, and low pressure, and we know that we measure that on a barometer. Rising air creates low pressure. So as the air goes up and up and up, there's less pushing down on the earth. So there's less pressure when there's less air there. Sinking air, on the other hand, creates more pressure. If the sinking air is now pushing down on the Earth's surface, it's going to create more pressure. It's just like if you put your hand on your leg and you press down, it's high pressure. But if you start lifting your hand away from your leg and going up and up, higher and higher, there's less pressure. You really don't feel anything on your leg anymore. That's the difference in high and low pressure. As the air goes up, we get low pressure. As the air goes down, we get high pressure. So putting it all together, the heating air, so our hotter air is less dense, so it begins to rise, and that creates low pressure. Our cool air rushes in to replace that warm air because something's got to take its place. So that cool air rushes in, or whooshes in, as I like to say, and it replaces that warm air. So that's high pressure coming in. As the air goes from high pressure to low pressure, the winds start to form. So the wind is moving from that high pressure, it's whooshing in or rushing in, and that low pressure area is going up. So wind is a horizontal movement. So it's moving east to west or west to east. It's not ever moving directly north to south. And the two types of wind that are created through all of this movement with low pressure and high pressure and heating and cooling are local winds and global winds. So local winds are where I am now. Am I on a mountain? Am I at the beach? Am I surfing right off the coast? Am I in a valley? Or am I on a ship way out in the middle of the Atlantic Ocean? Okay, so depending on where I am, it's going to be a local or a global wind. We're going to start with our two most familiar local winds. One is called a sea breeze, and we learned a minute ago that winds are named after where they come from. So a sea breeze is coming from the water. The cool air is moving across the water to the beach. It's going to be heating up and rising. A land breeze is the opposite. Remember, it's named for where it comes from. So our cooler air is going to be coming from the land, moving across, and it's going to be getting to the ocean or the water and moving across the ocean, and it'll begin to warm up. So a sea breeze, that means it's coming from the sea or a large body of water like an ocean, always happens during the day. And the reason it happens during the day is because the sun heats up the land faster. So the earth or the land heats and cools faster than the water. It doesn't hold that temperature. It's not moderate. So during the day, the sun heats up our land. The air above it gets warm because it's above that hot land. It starts moving across toward the water, but it's way up in the air. Once it gets over the water, well, hold on, the water's cooler. So it starts cooling down that air. The air starts falling. It moves across the water and whooshes or rushes back in over the land. And that movement of air from the sea to the land is what we call our sea breeze. And it's always moving from cool to warm. Because if you ever sat around and saying, oh man, that's a nice hot breeze I feel. No, you don't. Because you feel a cool breeze. Because it moves from the cool to the warm. So here you can see a really nice illustration. The land is heating up. You can see a sun, so we know it's daytime. As the sun heats up the land, the air around it warms up and begins to rise. As it rises, it starts to move across in the atmosphere, and it gets over the ocean. Well, the ocean is cooler than the land, so it starts cooling down that air. The air becomes more dense, because remember, when we're cooler, we're more dense. We want to squeeze together so we can start getting warm. It starts pushing its way across the ocean, and when it gets back to the land, it sweeps across the land, again, pushing that warm air up, and it'll start warming up again. And that is our sea breeze moving from the sea to the land because the land is hotter and we want a cool breeze. So, since we know what a sea breeze is, we'll know what a land breeze is because it's exactly the opposite. At night, the land cools down faster. So it doesn't hold that heat like the water does. The water is moderate. It doesn't cool and it doesn't heat up super fast. So at night, the land cools down faster. So my warm area is going to be over the water now. So the air above the water starts to get warmer and warmer and it starts to rise. So imagine in your brain it's rising. Then it starts moving toward the land. Whoa, it got to the land and the land's cooler. So it starts moving closer and closer together because it's trying to get warm. And it does that. It gets heavier and it starts to fall. It's more dense. That falling cool air creates that nice breeze coming off the land and moving toward the water. Once it gets to the water, it's going to start warming up again. And that constant convection is moving my cool breeze from the cool land to the warmer water. Again, here's a really nice illustration about how the ocean water is warmer because the land cooled a lot faster. So the ocean held on to some of its heat. It held on to it so it could warm up. So it now warms up the air. The hot air or the warm air is less dense. It rises. It moves across to the land. The land starts cooling it and whoosh, we have that nice cool breeze coming off the land into the ocean. And it repeats that cycle over and over again in our convection currents. So mountain breezes and valley breezes are just like land and sea breezes. One's going to heat up faster, one's going to cool down faster. So it's going to create this high density and low density. It's going to create warm and cool. So it's going to create those convection currents that are constantly making the cool air move from one to the other. So let's start with the day. So during the day, the mountain top gets heated faster than the valley. Think about it. The mountaintop's closer to the sun. So it kind of makes sense that it may get a little more heat. So during the day, that mountaintop gets kind of warm. It warms the air. So that air starts rising. It moves across to where it's over the valley, and the valley's cooler. So the cool air starts to fall as it gets more dense. It creates high pressure, because remember, it's pushing down now, and it's going to whoosh across from that high pressure to the low pressure. Because remember, we always want a cool breeze. Nobody wants a hot breeze blowing on them. So our cool breeze moves over to the mountaintop again, and it starts to warm up. This is really similar to the daytime sea breeze. So our valley breeze and our sea breeze are very similar. They both happen in the day, and they both move through high pressure to low pressure, valley to mountain, and sea to land. Our mountain breeze is exactly the opposite. During the night, that mountain cools faster, okay? So it cools faster than the valley. So the cool air is going to start moving down. And remember, when that cool air moves down, it's high pressure. When it gets to the valley is going to be a little bit warmer, so it's going to warm up that air. That air is going to start rising. When it gets way up and gets to the mountaintop again, whoosh, it cools down. And it moves from that cool, high pressure air that's coming down to that low pressure area where it starts to rise. And it's going to continue that convection current, that movement of air. So if I want some cool air at night, I may want to go down to the valley. So this is a nice illustration. In the day, you can see that the heat moves from the mountain top to the valley where it cools, and then the high pressure cool air begins moving up to the low pressure at the top where it heats. And at the bottom, you can see the night breeze is exactly the opposite. It moves in the opposite direction with the cool air coming from the mountain top and then rising back up into the air from the valley.